NASA's James Webb Space Telescope will be the largest space telescope ever flown when it launches in 2018. Once there, it'll be poised to unlock long-standing mysteries about the universe around us. With us today is astrophysicist Amber Strawn to talk about James Webb's potential.
So this is the largest and most complex telescope that NASA has ever built. This is a scientific successor to the Hubble Space Telescope. We're designing it to answer the questions that Hubble just can't quite answer. We'll be able to look back in time over 13.5 billion years to see some of the first galaxies that were born, and we'll be able to peer through dust clouds to see the sites of star formation within our own Milky Way galaxy. So we're really set to, I think, revolutionize astronomy again with this telescope.
Great, and you've just finished a really rigorous batch of testing.
So the key to success for any space mission like this is extensive testing on the ground. And here at NASA, we've been through a whole host of tests for years and years, but we've just finished some really critical testing of the telescope. So we test every component of these telescopes, from the smallest detectors up to the biggest structures on the observatory. Space is, of course, very cold, so we test everything in cold chambers. The launch of a telescope is one of the most violent events that the telescope endures, so we shake the telescope to make sure it will endure the stresses of launch. We blast sound at it so it will endure the pressures that it experiences during launch. And we've just finished a whole battery of those tests here at NASA Goddard. And right now, today in the clean room, we're doing some follow-up tests to those environmental vibration tests. So we're using lasers to measure the precise shape of the mirror to make sure that the mirror is still the right shape after all those tests. So the testing is going really well. We're really excited about the progress to launch, which will be late next year.
And what would you say is the most challenging condition to prepare the telescope for?
Well, of course, space is cold, and building an observatory on the ground in Earth temperatures presents a whole host of challenges to getting a telescope in space and working like it's supposed to. So, of course, materials themselves change dramatically under extreme temperature changes. So we had to build these mirrors and the sun shield and all of the different components in a way that we know that they will endure the extreme temperature changes that they will experience once they get to space. Now, this is really hard to do. We had to invent 10 brand new technologies just to enable us to build this telescope.
Is that right that the telescope is going nearly 1 million miles away from Earth?
We want to put Webb at a place where it can get very, very cold. And so that spot 1 million miles from Earth, that's about 4 times further away than the moon. We put it out there so Webb can get cold. And then from that part of space, it will basically orbit the sun in line with the Earth.
You've talked a little bit about the science that this telescope can do, but are there any particular scientific questions you guys are extra excited about it shedding some light on?
Well, I study galaxy evolution, so I'm interested in how stars and black holes form in galaxies and how those processes change over time. So I'm really interested in galaxies, but I think one of the most exciting things this telescope is going to do is exoplanet science. So we had this remarkable discovery just a few weeks ago of the TRAPPIST-1 planet system. And so with Webb, we want to be able to go one step further. Webb will be perfect for studying this planet system. We think that 3 of those 7 planets are firmly in the habitable zone of this star. And so with Webb, what we'll do is we'll watch the starlight as it filters through the planet's atmospheres. If they have atmospheres, we don't even know. But we'll definitely look, and if they do have atmospheres, we'll be able to determine the chemical components of those atmospheres, things like water vapor and carbon dioxide and methane, so things that would signal habitability.
Okay, and no telescopes before this have been sensitive enough to make that kind of measurement?
This telescope is going to have detectors that are going to enable new ways of doing this. And also the size of the mirror, the sheer size, will enable us to do this more precisely than it has ever been done before. This is by far the biggest telescope that NASA has ever sent to space. And the size of the mirror, combined with the efficiency of the detectors, is really going to enable whole new ways of doing exoplanet science, as well as galaxy science and stellar science.